everyone. Today the topic is a little different than usual for iOS developers, and I'm going to talk about building trust, mTLS for secure baby monitor connections. And my clicker is not working because it's turned off. Now it's working. Well, the QR code here for you to ask me questions throughout the presentation. I'm also going to talk a little bit about who am I. I've been doing iOS since 2015, which is a long time. I've been programming since I was 15 years old. I love it. And lately, I've been doing some side tracking outside of iOS, trying some content creation stuff with 3D printing that Adam mentioned. And on social media, I'm used to only having 3 seconds before you scroll away. So the only thing that I'm going to say is that I got a box with 5,000 toothpicks. And yeah, that's a lot. And if you want to see what I did with that code and 3D printing, you're going to have to follow me. I did post my content in Portuguese, but Instagram does add some captions. Hopefully, it's enough for you to follow what I do. But still, I am not a super security person, but I do have a very important reason to be talking about this, which is this is the tiny little hacker that lives in my house. And when I took this video, she was like 2.5 years old. And yes, she is a little bit of a vibe coder. She doesn't really know what she's doing, but 100% efficiency. Every time that she touches my code, she breaks it every single time. But I think like until she learns git commit and git push, I'm safe. And to protect those little hackers from the big bad hackers, we need to implement some extra security measures. IoT cameras have a bad reputation for being vulnerable. And there's lots of news around this. And with good reasons, because some cameras have really bad security features. So news about a stranger being able to talk to the microphone on a camera, being able to access videos from a camera. And like if you ask a parent if they prefer that their banking app was stolen, or if someone could hack into the camera that's standing in the room inside your babies, looking into your babies, they're probably gonna say that they prefer to have money stolen. So this needs to be treated very carefully. So in this presentation, I'm going to cover some topics about network security, which is trying to avoid people to steal stuff, data, information over the network without having access to like your physical device. Going to talk about certificate pinning, mTLS, which is the main topic here, how to implement this in iOS, and some of the challenges that I went through to kind of get this working across the app. Before I even start, we need to cover the basics, because I'm going to be talking about those 2 words a lot in my presentation. So public key and private key. Public key encrypts. So you have a message at a very high level. With the public key, you can encrypt things, and only the owner of the private key can decrypt and read that message at a high level. But sometimes it's also very useful because I really want to know if you have the private key, not someone else. I just want you to prove that you own the private key. You can't just send the key because it's private. So you can also use the private key to sign something, do a signature. I'll send you a message, you'll sign it, and I can verify that only the owner of that private key could have signed it that way. So I know that you actually own the private key. In a very high level, this is how it works. All right, so let's discuss a little bit of network security. Like I said, it's trying to steal information without having access to the device, just over the Wi-Fi. beginning of everything. Regular HTTP requests. The app makes a connection to the backend. Nothing is encrypted. Everything is plain text. Even like your cell phone company can read whatever you're sending. So definitely not good. And everybody heard about HTTPS, secure. What does it mean to be secure? So when you send a request from the app to the server, before it even starts, going to send you their certificate. And along with a lot of very useful information, it also has the public key. So the system is going to encrypt your request, and it's going to send back to the server, and only the server that owns the private key is going to be able to decrypt. So your cell phone company cannot just read the request anymore. It's not that easy. However, at OS level, it basically only checks if it's a valid certificate. So if it's within expiration, the domain matches, and some sort of checks. But if it's valid, Apple is going to say it's fine. This operating system is going to make it work. And this is how the man-in-the-middle attack happens, which I am going to change to person-in-the-middle attack, because obviously women can be bad people as well and be hackers. So I think it's time that we change the name. In this attack, someone purposely puts up a server that looks exactly like your server in an open Wi-Fi, like the conference Wi-Fi, for example. And they are going to send you a valid certificate. It's not the right one, but it's valid. So your operating system, your app is going to encrypt to the hacker instead of your server. And the hacker can basically read everything. So they can steal tokens, they can still basically view of all of the requests, and obviously that's information that you don't want to be leaked. And this is where certificate pinning comes from. I know what my server looks like. Like I can just Slack message the backend person, and they're gonna send me the certificate that our company uses. I'll put it in the app, and I'll do a simple check. If the certificate that the server is sending is the one that I'm expecting, then that's my server. Otherwise, I'll just cancel the connection, because it could be someone else pretending to be my server, the attack. All right, that's pretty simple. What about an IoT camera? So when I'm talking to a camera is acting up like a server. I make requests, I open WebSocket, I do everything that I would do with a server. But yes, it is bad if someone pretends to be a camera and puts up a fake camera to steal app information. But it is bad, much worse, if someone pretends to be a fake app and puts up someone pretending to be an app and take information from the camera, for example, the video, which we do not want. So both of them are in the same level of nobody can trust nobody. Plus, a camera can, although it is connected to the internet, internet connection is a bonus, like it's a plus. Everything happens on local network. Even if the connection drops, like in the middle of the night, you would not want to be, like, you use a baby camera to be woken up when the baby wakes up. Imagine like the internet connection drops and you don't hear the baby. That's not how it works. So the baby monitor camera works on local network. The video never leaves your house, just bounces around on the router. So we cannot just go to the backend from the camera and verify that this access is authorized. So we need something that works without internet, but we can assure that this viewer is correct. Like we trust that this app is who they say they are. And this is where mTLS comes from. It's just an extra step on top of certificate pinning. When I make a connection to the camera, camera is going to send me their certs. I'm going to do my verification, and I'm going to send back my certs to the camera. Camera's going to do their verification. If everything matches, we make a connection. If it doesn't match, connection is not made. Just recapping here. So at OS level, only verifies it if it's a valid certificate. If we do certificate pinning, we ensure that we're talking to our server and not someone pretending to be my server, which is very easy to do. Plus, certificate pinning is very easy to implement. There's lots of libraries. You can do it without a library with like one file. There's no excuses. Every single app should have it. Not all apps have it. 100% of the apps should have this. It takes a day to put together. Do it in your app. mTLS, on the other hand, it's not easy to implement. This is why I'm here. So in mTLS, both sides validate each other. Nobody trusts nobody. Everybody must pass their certificates. And on TLS level, like, I don't have to actually program this. All of this is happening by the OS. It does include a signature validation. So it proves it owns the private key. So both sides need to prove that they own the private key. And this is important as well. I am going to talk a little bit about code. I did explain this when she was a baby. She understood every single word. So I think you're going to be able to follow. Everything happens at URL session delegate. It has like this nice little thing where you receive a challenge. It does have a nice sync currently, which helps a lot. And you return what you're going to do with that challenge. If your validation fails, since you're doing it yourself, like you're doing your own logic, if something fails, it's best to cancel the connection. Oh, the certificate doesn't match, but I don't want a bad experience for users. But if certificates don't match, it might be a hacker, so it's better to cancel the connection if something fails. So to do the SSL pinning part, just handle the server trust. If the method is server trust, you're gonna get the certificate inside those classes there, make your check and return. And if it's mTLS, it's in the same function. And else if, it means that client certificate, which means that the server is asking for your certificates, you pass them on, and they're going to do their verification as well. For the pinning, there's two main ways of doing certificate pinning. The first one is Slack messaging your backend person. They're going to send the company certificate, and you're going to put it inside the app, the entire certificate. Just convert to data, get the server certificate on the request, convert to data, simple match. If it is a match, keep going. If it's not, just drop. This works perfectly well. A lot of companies do this. There's no need for third-party libraries if you want to do this. Just fine. But you do have to be careful because certificates expire every year or so. So when the certificate on the backend is going to change, you're going to have to put a change in the app, go to the app store. Older versions are going to stop working and that sort of stuff. So it depends on what's your plan. The other way of doing it is doing by public key. For example, you could ask the backend people to generate like 5 or 6 public keys from the backend private key. You put all of them on your app, and when the certificate expires, they can generate a new one using one of the public keys that the app already knows. So there's no breaking changes. You are good for like good 5 years. And if they're going to change for something new, you just ask them to give you the public key a few months early and put it on the app, and it's easier to avoid breaking changes. The second way, you cannot do it without a third-party library. Oh, you can. If you're going to use a third-party library, Swift certificates is a great way to wrap certificates that looks very good in Swift. There's also other libraries like TrustKit, Alamfire. I don't know, there's lots of libraries that do certificate pinning. But yeah, there's lots of options. It's very easy to set up. Every single app should have this. Something Swift certificates only has 260 stars. I bet there's a lot of people in here that have more stars than this Apple repo. So for mTLS, where does my certificate come from to send to the camera? I can't just bundle them into the app. They are per user, per camera. I have to generate them somehow. So what I do to create like this certificate is I create a private key, and I'm going to use Secure Enclave. Secure Enclave is perfect for this. It's a hardware chip that's specific just for this. It's outside of the main core. It's basically unhackable. Even I, that asked to generate the private key, I don't have access to it. Nobody has access to it. It's basically impossible to take a private key outside of that chip. But I can take out a public key, which I'm going to get, make a certificate sign request, send to my backend. My backend is going to self-sign a certificate and give it back to me, which I'm going to store in the keychain. Cool. But the API for mTLS requires an identity. Okay, so I just need to figure out how to build this object. If I look into the documentation, just like the Mayans and Aztecs did, like without asking ChatGPT, I went to the documentation. And it does say that an identity is a private key plus certificates. Okay, I have that. I just need to build this object, right? How hard could it be? This is an iOS 2 API, just so you understand. And looking to the code, there's something called sec identity create with certificate. It seems like exactly what I need. It's for macOS only. I don't have access in iOS. Cool. And if I look around, the only other way to really build a sec identity is using a P12 file, which is not what I want. I'm not going to email a certificate, a password-protected file to all of your users every 2 weeks so they install it on their phone. It just doesn't work. It needs to be something that I can manage through the code. And then I basically entered the land of unanswered Stack Overflow questions and Apple forums that are open for years and that sort of stuff. Now, if you do ask ChatGPT now, they do know the answer. They did not know the answer like a year and a half ago when I built this. So yeah, they're learning. The thing is, there was one or two of those questions that angels and very much angels, when they open the questions, have a long thread with an Apple engineer. Nothing gets sorted out. And then 6 months later, they come and they reply to their own question with, oh, I found out how to do this. Oh, that set me on the right track, finally. So basically, if you save your private key to the keychain, and Secure Enclave and keychain are kind of the same. You save your certificates to the keychain. You save them separately, but you query for an identity. They're going to give you an identity. Something happens there that they put together the object. This is not really documented anywhere outside of the guide that replied to their own question. But yeah, it works. The system, once I save both of them to the keychain, the system understands them as an identity, and I can take them out of keychain as an identity. And when I mean take it out, I just take it out a reference. The private key is never in memory. It's just a reference to the private key that's inside Secure Enclave. And this is kind of the code that I use to create the Secure Enclave key, that you need to put this very specific flag, so the system kind of understands this as a keychain. Again, thank you, the guy that answered to their own question. This is the sort of code that I use to query keychain for an identity, which I'm not going to spend time showing because it's a sort of code that makes baby cries. You have to use force and reps. There's no way around. You have to literally put a SwiftLeeds outside there because it does not work without a force and rep. And yeah, it is hard. But now I do have an identity. I can reply to the URL session delegate, and everything works. Great. And here's the magic. I did ask my server to generate the certificates for me, and the server gave me my certificates back. And you might be asking, like, what if someone steals the certificate? It's not a problem. Certificates are public. They're not like super private information. But because it proves it owns a private key, that certificate only works if it's leaving this device. Like if this specific device is using this certificate, it works. Otherwise, it's not going to work because the private key is here on this device, on the chip inside this device. And if someone just tries to connect to the camera with that certificate, it's not going to accept because the key is here. So that's how the magic works. If that wasn't challenging enough, I went through a lot more to get everything to work with all of the communication working with mTLS. Some of the workarounds that I had to do. Because yes, I made it work, but what if I don't have access to the URL session? Because I can't just override globally the entire thing on the app to put mTLS in all of the requests to the camera. There's no such thing in iOS. For example, in third-party libraries, there's some options here. If it's open source, you can do a pull request, but that might take a while and back and forth. You can make your own fork, but again, maintaining might be hard. And you can use Swizzling, which is just getting that specific function for the delegate to return your function and use your mTLS. I did use this just so I didn't have to mess with the library code until that gets supported. And this is what TrustKit does. Like if you use TrustKit, it's going to swizzle all of your methods in your entire app to put pinning in everything. So using very carefully, it might be good. But there's also one other thing that I went through. It was AV Player. AV Player doesn't use URL session underneath, so I can just swizzle. I don't know the implementation of AV Player uses something else. But AV Player is very, very good. We're not using AV Player to stream the video, like the live stream, but we do allow 24-hour history. And AV Player is just perfect for that. It supports a format called HLS. Is it HLS that allows for this very long format videos. Everything is built in. Like if you scroll, it's going to find exactly how to look for the file. But absolutely no support for mTLS, for certificate pinning, zero support. It does look like it has support. It has a function that looks like it. And after playing with it like for 2 weeks, you're going to find out that it does not work. And it took me a long time to figure out it does not work. I do have a blog post with more details just on AV Player because that was an entire challenge on its own. But eventually, what I did, and there's a lot of people that do the same thing for caching and other stuff, is I create a local server. I trick AV Player into calling my server instead of the camera. Whatever AV Player is asking my server, I'll just repeat the request to the camera because now I control the connection, and I'll pass the answer back to AV Player. AV Player gets happy. It does all its logic. I don't have to handle bytes and ranges and all of that sort of stuff. I just pass on the request and repeat the request. Once you know the answer, it's very easy, but it just took me a very long time. All right, so in summary, I talked about certificate pinning, which is trying to avoid the person in the middle attack, where someone can steal information using only the network. This happens at usually open Wi-Fi's like hotel, cafes. Someone pretends to be your server, and you're gonna pass your information to the hacker instead of the server. Not good. Certificate pinning prevents almost all of those attacks. You can bypass certificate pinning. Obviously, Syria is going bypass it very easily on his talk. But usually it does require you having access to the phone. So 100% of the apps should have certificate pinning. mTLS is the next step on top of this. Is 99.8% of the apps are never going to use mTLS because they don't need it. It's usually used in backend between server because it's used when there's no real client or server. Everything is on the same level, so you did need both sides validating each other. But in this case, with the camera, it makes a lot of sense because although I'm not just trying to protect the app, I'm also trying to protect the camera. So nobody trusts each other. Everybody must validate each other in order the connection to work. I talked about secure enclave and the keychain and the sort of quirks that I had to go through to actually reply to a mTLS request. Secure enclave is great. It keeps private keys, and it does all of the cryptographic operations inside there. I don't have to do any of this myself in the code. I literally just pass the identity to the OS, and app is going to handle that. Everything is in the TLS handshakes and all of that stuff that I don't understand, but they handle it. I just understand how it works. And some of the workarounds to enforce mTLS in all connections to the camera. So basically, undocumented APIs, getting to work with Swizzling for libraries, that weird local server that I had to do for AV Player. There's lots of synchronization for you might be trying to connect to 3 cameras at the same time, and all of the 3 cameras need refreshing the certificate. So one needs to actually refresh and the others need to wait, and all of that synchronization code needs to be taken care of. And I mean, this went on and off for a year. I was obviously not working on specifically this for a year, but all of the time that a new feature we needed or something else that we needed, we need to revisit this, come back, improve, and it was an on and off work for a long time. We're probably not gonna have time for questions. Adam's gonna come here and say that we don't have time for questions, but here's my LinkedIn, here's my Instagram, if you like that sort of stuff. And yeah, although I am not a security person at all, here I am on the stage talking about a very specific topic on security, but like all of us need to know a little security, otherwise we would make it too easy for hackers. So put certificate pinning on your app. If you don't have it yet, do it tomorrow. And yeah, that's it. Thank you for listening.